Hi, this is Todd with Land of Math. In this video, we're going to look at the 10 key and basic concepts that you need to know if you're hanging out in the world of middle school math. So all that's coming up next on the Land of Math. In this video, we're going to look at 10 key middle school math properties. The first of these properties is something called the multiplication property of 0. This is one that we're probably fairly familiar with. If you take any number, in this case 5, and you multiply it by 0, you always get the product or the answer 0. So 33 times 0 equals 0. If we took 1 million times 0, it would still equal 0. So any number times 0 gives us 0. Our next property is the commutative property of addition. When I think of the commutative property, I think of my morning commute. And my morning commute is basically my travel or my journey from home to work. And when I'm done with work, I travel back home. The way this would relate to math is basically if I'm traveling from home to work, the distance I'm going to travel from home to work is going to be the exact or very close to the same distance from work back to home. So when I'm looking at a math problem and I'm looking at, say, for example, 3 plus 2, going 3 plus 2 is going to be the same as going 2 plus 3. So in this case, both would equal 5. Just like 10 plus 3 is going to equal 3 plus 10. It doesn't matter the direction I add them. I'm going to get the same answer. For this example, both are going to be 13. That leads us to our next property, the commutative property of multiplication. This is just like our commutative property of addition. If I take 2 times 5, that answer is going to be the same as 5 times 2. In that case, that would both been 10. So if I have 4 times 5, that would equal 5 times 4. Both of these, when I multiply them, 4 times 5 is going to be 20, just like 5 times 4 is 20. The direction or the order doesn't matter. Now, you'll notice there's actually no commutative property of subtraction or division. If I take 10 divided by 5, I get 2. But if I do it the other direction, 5 divided by 10, I actually get 0.5. Different answers, so they're not equal. Just like there's also no commutative property of subtraction. If I go 8 minus 3, that's not equal to 3 minus 8. 8 minus 3 would equal a positive 5, but 3 minus 8, that's going to give me a negative 5. And those are different answers, so it's not equal. Our fourth property is the associative property of addition. When I think of this, I usually think of the word associates, and I think of that with like companies, like real estate companies, for example, like this one, Carroll Goff and Associates, or Lepi and Associates. And it's basically just a group of people. Right between these two businesses is another company called Web Financial Group. And it's just basically saying it's a group of people. In the world of math, we can group numbers together. So if we're adding, we have like 3 plus 4 plus 5 on both sides. It doesn't matter how we group them. So on the left side, if we group the 3 and the 4 first, that gives us 7. 7 plus 5 is going to give us 12. On the right side, if we group the 4 and the 5 together first, that's going to be 9. So 3 plus 9 is also going to equal 12. So it doesn't matter which way we group it, we're going to get the same answer. In this case, 12 is going to equal 12. So here's another example. So let's say we're adding 10 plus 5 plus 1, and we're going to do this on both sides. We can group it either way. So on the left side, if we group 5 plus 1 first, it's going to give us 6. 10 plus 6 will equal 16. On the right side, if we group the 10 plus 5, we're going to get 15 plus 1. It's also going to equal 16. So either way we end up with the same thing. Property is the associative property of multiplication. And this is very similar to the addition property. If we have three numbers, like in this case, 4 times 3 times 2, on both sides, we can group them either way and get the same answer. So on the left side, we're going to group the 4 and the 3 together first and get 12. 12 times 2 is going to equal 24. On the right side, we're going to multiply the 3 and the 2 together first, which will equal 6. 4 times 6 is also going to equal 24. So they're equal. Here's another example where we can group them together differently and get the same answer. So if I'm multiplying 3 times 5 times 6 to both sides, on the left side, if I group the 5 and the 6 together first, that's going to be 30. 3 times 30 will give me a total of 90. On the right side, if I group the 3 and the 5 together first, that's going to equal 15. 15 times 6 is going to give me 90 as well. And so again, they're equivalent or equal to both sides. You'll also notice that there's no associative property of subtraction or division. So if I look at this subtraction problem where I have 15 minus 5 minus 4 on both sides, on the left side I'm going to group the 15 minus 5 first, which is 10. 10 minus 4 would be 6. But on the right side, I'm going to group the 5 minus 4 together first, which is 1. But 15 minus 1 is 14. So they're not equal, so this doesn't work. The same with division. If I'm taking 20 divided by 10 divided by 2, on the left side, if I do the 20 divided by 10, I get 2. 2 divided by 2 would be 1. But on the right side, if I group 10 and 2 together, that would be 5. 20 divided by 5 is 4. And again, they're not the same, so it doesn't work. All right, next, number 6, the identity property of addition. When I think of identity, I think of something that tells you who you are. So for example, a driver's license might be a type of identity for a person. For the number 7, if you're trying to stay who you are, you're thinking, what can I add to a 7 to keep it a 7? And the answer is we can add 0. Anytime we add 0 to a number, that number just stays the way it is. So 25 plus 0 is still 25. When we get to number 7, the identity property multiplication, now you're asking yourself, what can I multiply a number by so that number stays who it is? So the answer here is we always multiply by 1. So 8 times 1, the number stays 8. 30 times 1, the number stays 30. So by multiplying by 1, the number stays what it is. So number 8, the inverse property of addition. So what we're asking in this property is what can I add to a number so that it equals 0? So if I start with 5, what could I add to 5? Well, the inverse of that would be a negative 5. 5 plus negative 5 equals 0. On the flip side, if I have a negative 12, if I add a positive 12, that will also equal 0. Now with the number 9, inverse property of multiplication, what we're trying to figure out is what can I multiply to a number so that it equals 1? So if I had 5 times what would equal 1? Well, the answer would be the fraction 1/5. So to kind of show that, we know that the whole number 5, I can write as a fraction 5 over 1. So if I take 5 over 1 times 1/5, I would get 5 over 5. And then that would simplify to 1. So the same here, if I have the number 21, and I want to know what can I multiply it to equal 1, the answer would be 1 over 21. And again, I could put it as 21 over 1 times 1 over 21. It would equal 21 over 21, which would simplify down to 1. All right, our 10th and final property, the distributive property. Distribute means like to share, to pass out. So in this problem, we're going to share the 10. And we're going to share it or multiply everything inside the parenthesis. So we're going to go 7 times 10, or 10 times 7, which would be 70. And then we're going to go 10 times, and I'm going to treat this like it's a negative 2. So 10 times negative 2 would be a negative 20 or minus 20. Notice I'm not doing anything to the 5 because it was not in the parenthesis. Now I can simplify this down. 70 minus 20 would be 50, and then the 50 plus 5 would be 55. In this next example, we're going to share the 2. Inside the parenthesis is 5x plus 1, and then outside the parentheses is a plus 3f. I share the 2. So 2 times 5x is 10x. 2 times 1 would be 2. And then we're just going to bring down the plus 3f. Notice they all have different variables, so this would be as far as I would go. Well, hopefully all this was helpful. Hopefully it made sense. If it did, we'd love for you to give us a thumbs up, and we'd really love it if you would subscribe to our channel. So until next time, we'll see you later on The Land of Math.